All right, so I'm going to be answering this question here. So we're supposed to figure out the area inside both the circle and the cardioid. The cardioid's inside is here, so everything inside here will be the cardioid, and inside the circle would be in here. But we want to make sure that it's inside both, so we're going to make sure that that the area will cover this. Okay. All right. Now that being said, in order to figure out what the equation for the area of this, we need to take some precautions here. Is that first, this is where theta is equal to 0, right? But what we want is that notice how initially right here we see that the cardioid right here is the one that's the one that's extending as radius. Okay, but once we get here, all right, and in order to find the theta of this, we set that equal to set the radius equal to each other. So we say 3 cosine x is equal to 1 plus cosine of x. And when you solve for theta, you'll get theta is pi over 3. All right, and then when you get theta equals pi over 3, then it changes from the cardioid to the circle. So now the circle is in the lead here, all right? And that's the same for the bottom too. Now notice here that the shapes here is perfectly symmetrical to the bottom. It's symmetric to the x-axis. So therefore, all you have to do is just find the area of this and times it by 2. And that's all you have to do, all right? So we're going to set that. So what we're going to do is going to find the area of this part up here, right? And then we want to make sure that, and we have to make sure that this part here, and remember, the circle is in the lead here, right? After here, the circle is taking its area. So we need to find when r equals to 0, what is the theta of the circle? And when you look at the circle, you set r equal to 0, and theta will equal pi over 2. Okay, so then now we can complete our area typing. So then we'll type the area. All right, so 0.5 times the integral from 0 to, and we want to go up to pi thirds. So pi thirds, and then because remember, as I said earlier, the radius is leading on the cardioid here, right? There, and then you extend it all the way up to here. So we're gonna put 1 plus cosine theta, and you square that to dx. All right, and then you want to do that, and that's the integral for that part. Okay, and then you want to do that. All right, and that gives you the area from 0 to pi over 3, and then you want to add the integral from pi over 3 to pi over halves. So you want to go pi over 3 to pi halves. And remember that from here to here, it's the blue one that's leading its radius. So it'll be 3 cosine theta squared, right? Because it's r squared theta, right? And you add these two together. All right. Now remember how I told you earlier that it was symmetrical to the x-axis. So the area that's 0 from 0 to pi 2 is exactly the area that's here. And since we want the whole area of that, we're going to times that by 2. So that by parentheses, and you times that by 2. And that should be the answer. And then I'll write this down on the written response so that we could kind of see how it's going to be completed. And then I'll do the same thing for part B in the written responses too. All right. Bye. Oh, and please make sure that and please give me feedback whenever. If you have like any feedback that you would like to give me, I'll be very highly appreciative of it. Thank you.